Welcome to section 6.1, page 2. A central angle is a circle is an angle whose vertex is in the center of the circle, so the vertex is center, and whose sides are radii. So this is a radius and this is a radius. So it kind of makes sense. Central angle, it's in the center. Okay, the vertex is in the center. So we would say that angle APB is a central angle of circle P. And what is its intercepted arc? That's a new word for us. It's what the ends here map out the arc. So we would say AB. And the way we draw this is we go like that, put a little arc on top. Okay? So Theorem 6.1.1 says a radius that is perpendicular to a chord bisects the chord. So let's talk about, first of all, we need a radius. Okay, so let's put the center of the circle because we need the center to make a radius. And then we're going to go ahead and do this with it. We're going to draw it to the circle. Okay, so that's our radius there. And then if it is perpendicular to a chord, so I'm going to draw a chord that's perpendicular here. Okay, so that, if it's perpendicular there, then what we say happens is it bisects the chord. Okay, so we're going to say if, we need some letters on these things. Let's call this P, let's call this Q, let's call this A, let's call this B, and let's call this point right here. Let's make it in red so it's easy to see. We'll call that M. Okay, so if this radius PQ is perpendicular to this chord AB, then what happens? Then the radius bisects the chord. This radius chops this chord in half. So AM would be congruent to MB. Okay? Which means that AM is equal to MB. Their lengths would be equal. Okay, so central angle postulate tells us that in a circle, the degree measure of a central angle is equal to the degree measure of its intercepted arc. So we have here arc BC. Notice it says if it's a central angle. So this angle, BOC, is a central angle. And that angle is supposed to measure the same thing as the arc. That's what this postulate says. So we know that this angle measures 90 degrees because it has this right angle symbol here. So we know the angle measures 90 degrees. That means this arc measures 90 degrees. So we put them both at 90 degrees. Okay? Now they're asking us for the measure of the arc ABC. By the way, that's as good as I can get on my word processor to make the little arc symbol. Okay, so the measure of arc ABC, again, it is a central angle. Its vertex is here in the center. So the measure of this arc would be equal to the measure of this angle. So because that's a straight line there, we know that the angle measures 180 degrees. All right? And lastly, it says we want to know the measure of angle or of arc ABCD. ABCD. So everything except for this piece here. Well, we know we're going around here, that's 180, and then we're going to add in another 90 because this angle would also be 90. So 180 plus 90 would be 270. Okay, so the angle we're talking about is this one right here. Okay, and that's 270. And when we get a big angle like this, do you remember what it's called? When we go past 180, it's called a reflex angle. All right, so that's how we're going to measure those. It says, note, the sum of the measures of the consecutive arcs that form a circle is 360 degrees, meaning that if we go all the way around here, we get 360 degrees. Just like the angle measures 360, the arcs will measure 360. Okay, so let's try problem number 6. It tells us if the measure of angle O is equal to 48.3. So that's this. 48.3 degrees. Okay, find the measure of the arc, DE. Well, what kind of an angle is this? It is a central angle. Because it's a central angle, the angle and the arc measure the same. So we're going to say the measure of the arc, DE, is equal to the measure of the angle, DOE. Since angle DOE is a central angle. Okay, so the measure of arc DE would equal what? Well, the measure of this angle, 48.3 degrees. That's all there is to that. Okay, so if you remember back, we have some addition postulates. We have the angle addition postulate, which says if you add two smaller angles and they're side by side, it equals the bigger one. We have a segment addition postulate that says if you have the two segments next to each other, it'll equal the larger one. And now we're going to have the arc addition postulate. So let's see what it says. It says if AB, arc AB, and arc BC intersect only at this common point B here, then if we add this measure, the measure of this arc plus the measure of this arc, guess what? It equals the measure of the whole thing. Okay, so that's what that says. So let's try number 8. It says if the measure of E, C, A, B, D, that arc, if all that way is 312. So let's use a blue pen here. So we start here and we go around and around and around and around. Where do we stop? We stop at D. Okay, that measures 312 degrees. Then we need to find the measure of DOE. Well, to go all the way around, what do we know it has to be? This piece right here has to be 360 minus 312, doesn't it? Okay, so what does that give us? That gives us 48 degrees. Okay, but if we're going to work it out, we're going to say that the measure of angle, or not angle, we're doing arcs now. Let's see. The measure of arc ECABD plus the measure of arc DE has to equal 360 degrees, the whole circle. Okay, so if we know that this big guy is 312, then the way to find the little one is just subtract. Okay, so the measure of DE would equal 48 degrees. Okay, so actually I should write up above here by the arc addition postulate. Okay, all right, that's it for that. One more definition before we go on to the next page. It says an inscribed angle of a circle is an angle whose vertex is a point on the circle. So notice our angle is going all the way, the vertex is here on the circle, and whose sides are chords. So they go all the way, okay? And so we say here, looking at this picture, angle ABC is an inscribed angle, okay? Or angle ABC is inside a circle, okay? All right, that concludes page 2.